Started. Hello. Carter. All right. Welcome, everyone. I hope you're finding yourself in the correct room. This is the one where we're going to do some coding. If you have never started OpenSpace, you're in the wrong room. Cool. While I had it up, I just wanted to make sure that it's actually really working. Searching for things, a lot of planets. Cool. All right. So, while we're here, in the next hour or so, we'll be talking about the different pieces of OpenSpace that you can customize by coding, mostly in Lua, but we're going to be looking at some of the asset files and how all of that stuff is set up. So I was thinking, in order to tailor this to benefit the most people, I was just going to quickly, by show of hands, see, like, in terms of experience of OpenSpace, like who has done any type of coding inside of OpenSpace before? It's a good half or so. Made assets. Made any button pages using a web programming language. Cool, it's a good distribution. I'm looking forward to this. So there's, particularly in the beginning, for you who have done some coding within OpenSpace, within Lua, it's going to be a bit of repetition, but we'll be jumping into some of the newer stuff pretty soon as well. All right. Oh, before I get started, if you want to follow along, we'll make the URLs available on the slides as well. But if you go to presentation.openspaceproject.com/2025-OpenSpace User Meeting, so OUM, you're going to end up on a web page that looks like this, and we're in the coding, scripts, and custom navigation. So you're going to have access to my slides as I'm going through them. And the slides will be updated depending on the questions that we're going to have. So it's a living document, but that it'll also stay around after the meeting. So if you want to go home to your institutions.
I got to 2025. What's after that?
-OUM for OpenSpace User Meeting. So if you want to take the slides home to your institutions and talk to the other people and get them learning, OUM. It's a dash between 2025 and OUM. So yeah, the web page will stay up, so you can look back on it in 6 months and talk to other people, or if you want to remember some of the things we talked about. In particular, since we're going to be doing some exercises throughout this, it's quite useful to have this open because you'll be able to copy and paste things from the slide into a text editor. So you don't need to type things manually, which can be quite annoying, even though it can be a bit more instructional as well. But I would recommend just going there.
The website isn't working.
The web page isn't working.
Yeah, it says the site can't be reached. Other people are getting curious.
So it should be presentation.openspaceproject.com/2025-OUM.
I see it, but it's just the image of the moon.
Oh yeah, if you press the right arrow, it'll go to the next. It's just a PowerPoint, but online.
Oh. Oh, yeah, right.
I'll.
Can you send the link in the Slack?
I can send the link in the Slack. That's a fantastic idea.
Yeah, that worked.
Great. And then, yeah, right arrow, left arrow. I think everyone has used PowerPoint before. So, cool. So, more questions at the moment, then we'll get started. So, we'll be talking a bit of the scripting. So, as some of you might be aware, OpenSpace has a built-in scripting language that we're using for essentially controlling almost anything that is happening in the software. So with the exception of the camera position, with a caveat that we're going to talk about later, and the simulation time, which with a caveat that we're going to talk about later. Everything in OpenSpace is controlled through this scripting interface that is using a language called Lua, which it's a very easy to understand programming language, even for people that never programmed before. It looks somewhat like text, unless you want to make really complicated things, then it becomes an actual programming language. And the other part, the other benefit is that Lua is Portuguese for moon, so it fits the whole theme of OpenSpace. And the guy I was sitting with next to NYU, he knew the developer, so I mean there's a natural connection, and it's a nice programming language to work with, which is the main reason. So at the bottom of the slide, you can see some of the examples of things you would be able to do in OpenSpace using Lua. So for example, the first example is setting the time to the 1st of January 2025. So as I said, it doesn't look very programmy. It's more like instructional in a way. The next one is setting the scale of the Earth to 1,000 times, so we're making the Earth 1,000 times bigger. The next one is we tell OpenSpace to take a screenshot. If you want to make marketing material or just a desktop background, you can do that with that.
I'm just breaking in to say that there is a little distortion on these speakers. Our technicians are working on it. The audio is clear on that side of the room, so if anybody's bothered by it, you should feel free to move over.
Then the next example is adding an exoplanet system. So that is actually what the user interface is using to add. If you want to go to a new exoplanet system and add it into the scene, that's the actual script that gets executed on the back end. And then lastly, this one gets a bit more involved because it involves calling two different functions. First, we get the current time in OpenSpace, the current time on your computer, and then set the time in OpenSpace to that time. So basically, you have the little, in the time, this little now button to set the time to whatever it is right now. That line is actually exactly what is being executed. So my point here being is like, I wasn't like exaggerating when I'm saying that everything's controlled via Lua. Like the only thing, quote unquote, that the user interface does, it generates Lua codes to OpenSpace, and then they get executed. So anything you can do with the user interface, you can do manually and better, because there's a lot of things that are exposed in the scripting interface that are not exposed in the user interface. So that's some of the examples that we're going to go through in this time that we have. So I was saying it's an easy language. I mean, it's relative, but this slide shows the entirety of the Lua syntax. So if you understand this slide, you understand everything about Lua. One of the nice things is that it has only very few types of different data. So normally if you go with programming languages, you have a lot of different data structures. Lua has only these. So there are strings, which are basically just pieces of text. There are numbers. That's it. There's Boolean, so it's true or false, like basically a binary state. Comments, which are probably always a good idea to leave behind. And then the only more difficult structure is called a table. So it's also called sometimes an associative array or a dictionary, depending on which language you're coming from. It's basically a key value pair. So in this case, for example, we define a new table that has two keys, one called name, one called value, and the values, okay, the examples are not very great written. The value for the name key is called ABC, and the value for the value key is called 0.25. So basically we can combine different values together into one object that we can then later pass on to someone else who might be interested in it. So for example, in this case, we are printing whatever is behind that table name, and if we were to execute this, we would see ABC, because that's the value behind this key. So these ones are the same. Yes, question?
On the comments example, for the multi-line, you've got the double open bracket. Is that required after the double dash?
So the question is, with the comments, we have these double open brackets for a multi-line comment, if they are required, and yes, they are required. Okay. This is how Lua defines a multi-line comment, so we can have, otherwise we would have to have these dashes before every single line, which can get a bit annoying. Okay. So yeah, so it's basically double dash, double open square brackets, and then closing them with the closing square brackets and a double dash again. All right. The The last data structure that we have are functions, which are basically packaged things that we want to do on multiple objects at the same time. So for example, in here, we define a function that is called do something that takes one argument. And whenever this function gets executed, we print out you said whatever the argument is. So if I call this with this string, hey, it'll say you said hey. If I call this with math.py, we'll print out 3.14159. So basically this allows us to start building reusable components. And as you can tell already, probably, like this print function is a function that Lua defines. So we'll just execute them. So there's a whole bunch of different functions. And with this knowledge under the hood, if we go back one slide, you'll understand now. We have a string. We have a string. We have a number. And actually, the functions that we're calling here are just the same functions that we defined on the next slide. So there's everything that you saw on the next slide is explained, explaining this one. Right. To hammer that point down once more, everything you do is Lua scripts. So if you fly around and you turn off the rotational friction with the F key, for example, what's actually happening under the hood is that OpenSpace is executing Lua scripts. So you can do exactly the same thing, but I mean, it's a lot more typing, but you would be able to do the exact same thing by just typing in these commands. So if I copy, paste it in, now the rotation friction is off. It's on. Now the rotation friction is on. So it's exactly the same thing as pressing the F key. So there's the reason why I'm showing this is that there's a lot of different examples within the existing OpenSpace code that shows you how to use different scripts that are worthwhile looking at. Yes, question?
Stupidest question.
Yes.
Okay. To execute one of that little bit of that code, you have to press that upper left-hand corner, that special key, and then you insert whatever you pasted, which is a function. It's just paste. Is that true? What I just said?
Correct. So in order to execute it, you press. In order to get this console, which we're going to have in a second, you press the key that is left of 1 on your keyboard. Like regardless of which keyboard layout you're using, it's almost always going to be located there. And if you have OpenSpace running, it'll pop up this console at the top, where you can print, basically, or like enter any type of Lua code and execute it. So that's what I was doing here by just pasting the code from the slides and then executing it with enter.
Can the code itself be, rather than the name of the function, can the code itself within the function be pasted?
Yes. This is multiple lines. You can paste as many lines of code as you want. Yeah. All right. So everything is Lua scripts. So that means that's not what I wanted to do. If you have OpenSpace running and you've been interacting with it, in your OpenSpace folder, there is a folder called logs, which contains at least one, maybe more, scriptlog.txt files. If you open them up, it'll contain all of the scripts that OpenSpace executed since you started it. So you can, if you want to know, like, oh, how does the user interface make Mars fade out and then disappear if I click this checkbox. So now I did it. And if I go back here, we have a function called OpenSpace.fadeOut that will fade out scene.mars.renderable. So now by just doing it in the user interface and then looking at the script log, it's very easy to figure out like how do different things in OpenSpace actually happen. So if I want to do this, for example, for Earth now, I can copy. Get to Earth. I open the console again, paste, and instead of scene.mars, I want to say scene.earth. And if I execute this, now Earth fades out. So now we can do multiple things. So if we get back Earth I can now say, let's fade out Earth, and let's fade out Earth atmosphere. So now I have 2 lines in one go. I execute both of them, and both of them fade out. So this is now the first thing that we wouldn't be easily able to do in the user interface, because I would have to quickly click the 2 checkboxes next to each other, hope I don't make a mistake. But now I can very easily, fairly easily, do that in one go. And if you're in a dome environment, for example, the console is only visible on your own screen, not on the dome. So everyone thinks you're a master at clicking things, but it's actually just copy-pasting things. As of version 21, which I hope everyone has, there is a window that is available called script log that gives you access to that same page. So you don't necessarily have to go to the text file. It's pretty new, so I still have it memorized to just go to that file, but it's all here. All right, so, yeah.
Alex, that was under Windows?
Yes, the window is located under Windows and then script log. If you do have version 21.2 and it doesn't show up, you have to first go under View, GUI settings, and set it to at least advanced user. So one of the changes from 21.0 to 21.2 is that we're now hiding the script log by default, because if you're a normal user, quote unquote, you might get scared by the script log. So now you have to tell the system that you're an advanced user, and then the web page shows up, or the panel will be available.
Thank you.
Any question? All right, documentation. So I was talking about it earlier. There's a lot of great documentation that is available, which particularly once it goes to the scripting, it's invaluable to go through. So docs.openspaceproject.com, there's a direct link here as well, but you'll find it under references, and then there's a scripting API. The scripting API is basically all of the different functions that we have written that you can use inside of OpenSpace. So if I go into the OpenSpace one, which one did we just have a look at? We had a look at fade out. So if I scroll down, we have the fade out here. If I click on that, it'll tell us how does it look like, what are the different parameters. And before we were just calling fade out with the identifier, but we left out the fade time. See that there's a little question mark, which means that it's an optional parameter. So we don't have to provide it, but we can. So for instance, getting pretty full here, and now we need to find ourselves a new planet. What we can do now is, if we do fade out moon, now we can provide the other parameter, which now I know that it's in seconds, but it's going to say it in the documentation. So I can say like, oh, let's fade it out over 15 seconds. So now while I'm talking in the background, hopefully the moon starts disappearing over the next 15 seconds. Again, this is a feature that's not natively available in the user interface. We just have a default value that we decide was good. But like mostly you know better in your cases what kind of timing you want, particularly if you want to do other things at the same time. So these ones are how you would get to these parameters. It says in seconds. So basically here the idea is if there's a question mark at the end of it, that means that it's optional. And hopefully we have a good default value. Not all of them will necessarily have one. If there isn't, let us know, because that's a bug that we need to fix. But yeah, so there's a lot of different functions, and we're not going to be able to go through all of them because there are literally hundreds of them. And in my view, like the real power of OpenSpace comes from the ability to combine these different functions together to do something interesting. So going back to the example that we had in the beginning, just printing out what the current time on your computer is not a very interesting feature. Setting the time is moderately interesting, but by combining those two things together, I've now made something that is bigger than those two individual functions.
So is nscript script that will execute after the fade time has completed?
Correct. Question is what nscript means, and yes, it's exactly correct. That is a piece of text that gets executed as a Lua script once the fading is finished. So probably going to make a mistake, but let's try it anyway. So let's say we want to fade out over 2 seconds. And once we're done, I want to fade out, well, let's do fade in, which is, I mean, I don't need to explain what this does. There we go. So we're fading out the moon over 2 seconds, and then once it's done, we start fading in the moon again. So it fades out, and then it fades back. So yes, and now we could add another end script after that to start building chains of actions. Great question. Yep, this is how we get to the scripting console. So you press the tick mark, and it opens up at the top. There is up arrows, goes to your previous commands if you want to execute them again. Pasting works. On copying, we're still working on that. So now we're getting to the first exercise. If everyone has a computer open with OpenSpace running, basically over the next, let's say 5 minutes, try and go through these. So basically just printing anything. To make it easy to see, I would go with a print warning or print error, because then something pops up in the bottom right that lets you know about that you did something correct. And then the other ones, scaling up the moon, scaling up the size of Jupiter, and then, the fourth one is a bit more involved by increasing the size of Jupiter by a factor of 2, but without actually typing in 10,000. So it's like combining multiple functions together. And I'll be here if there's any questions. We do have a couple of laptops available if you want to borrow one. It's going to make things a lot easier. Should we can do on the old version as well. And we can try to do troubleshooting.
And then I tried to change it back for myself, and I broke it.
First, the name of the property and then change. Inverted commas to make strings. Then you for example, yes, you get the node, we use recursion.
Oh, my text must be. Text by itself is like this. It's okay. I can still see. I don't know how to use talking.
Or alternatively, if you know how to get there in the user interface, okay, just change the property and then the script will this is the correct one, but C. By default, I would assume.
Are you getting power? You are. I like clicking around. No, you're not. Okay.
I got a question. Yeah, it's all wherever. No issue. On the other hand, I don't know this shit.
Okay.
4 years. 4 years. Second year, we've seen OpenSpace set property values, signal, down, yeah, those are the numbers I'm supposed to put in.
Yeah, so first, this one needs to be a string, so we need a string marker. Around seeing the scale. So the first argument is the set property value single function is string. Yeah, and then one at the end. I'm trying to figure out the syntax. Then the value that we want to set it to. The value that we want to set the property to is the second argument.
So that was all.
Yeah.
The second word is
What the value of the scale should be in a number. Whatever. And then close brackets.
that does what that is supposed to cover.
Yeah, exactly. Yeah, and probably now inside of the moon, because you're close to Earth and you scale up the moon, so that's why it's probably dark right now. So if you zoom out, you'll probably see.
I'll sit next to Ellen.
How's it going?
Getting stuck on board.
Stuck on 4.
Did it work for you?
No, I'm just moving.
Your move.
Yeah. Our part is not working.
So I just keep entering the same.
None of this is all.
So
open the function by opening parentheses. So that you want to know what are the arguments.
I'm just getting this.
Very argument for this game. Yeah, first, for example, scale and scale.
Capitalization.
Yes.
Lights got power down.
While you're back there, you need to start.
By the way,
Since this is a string, you need to start with an
we
inverted
got
comma.
power down.
Back here.
Or single comma. Before the closing parenthesis, the second is exactly this. So comma for the second one. And then closing the parenthesis. Yep. There we go. Now, times figure. Sweet. Send you the email with part one. You don't have to connect them. You can do them separately as well.
Right. Then it applies on these 3 to 5 seconds, so you can be able to start doing control. Agreed consideration 5 seconds is not given the code to be applied. It was assigned elsewhere with reference to the speed at which something was going.
Yeah, that was, for example, the example that I showed with the fade out. The set property of the sim takes a current argument. That is how long should it take to get there. Nice. Just tell me how it's going. Yeah, as long as it's easy, you just talk to me really quick. Okay, clear. Where's the tuition? Yeah, so I'll just ask a real general question, and remember, you just talked to me. How's it going so far?
Well, I'm very pleased that I'm learning to swim now. I am the programmer training and surgeon. This is a little bit hard for me. Why is hard? It's the fact that I have no memory of what was on the previous screen. So I'm sure it is more data than the screen at the same time. So while I can do what's there, it's hard for me is what is the machine is.
Same thing now. I need the screen. So is this your first introduction to OpenSpace? Okay. So I'm going to ask you one more question.
I know OpenSpace is before that part of you, there's a universe. I've implemented this software. I've used it for 2 decades. This is not new. This way to is very exciting to start playing with. Controlling it in a programmable way so that things happen. So that
So what was the person who was interested in OpenSpace?
Sets it, and then the other one just Oh, probably should have focused.
Yeah, there was no error message.
Yeah.
Show me.
One second, let me put Saturn to its
Oh, yeah.
We shrink Saturn again.
Yeah, shrink Saturn down. Okay, so are you trying to do number 4?
Yeah.
Okay, so what? Yeah, that's right. So basically, you want to set Saturn, but where one is, you want to follow the okay, so then that's what it says. Dot and cross about 5,000.
Call the value
Yeah, so then, so the thing is, you need to do this ahead of,
Okay.
oh, you don't need the times. And then property value, then so you have to call it property value, so you want to do the string, but instead.
Okay, so we're calling the line.
Yeah, C Jupiter. And then you do
Sweet. Thank you. Computer windows, so
Adrian can call us. But yes, exactly. I was like, how do that like?
calling the value we already set for Jupiter
Yeah.
to Saturn here.
In the print.
Great. Sorry, in the I mean, it's collaborative, right?
That's what you're thinking.
I remember asking Dan, like, well, how do you make these things? Like, I know.
I just want to base everything all the time.
When we did at the academy, we had the
All right. Do people feel ready to move on? All right, so in case people haven't noticed it, if you go by one slide more, you get the results. But this is for learning it, so it's good if you didn't notice it. But basically, sorry, if we want to print something, we have a function called print info, or print warning, or print error, print fatal. There's different ways of printing that are just different severities of how much do you want the user to know about that something happened. The next one, we have the set property value single. So we give it the name of a property, and then whatever value we want to set it to. How we would get to a name of a property, I hear no one ask. So let's say, well, now I'm at the moon. Can go to the scale. So we have the scale down here. Everyone say it with me. Everything's a Lua script. So if I change the scale by hand, I'm now generating Lua scripts that get executed, which will have to have that property name in it. So if I go to the script log, it'll generate exactly the script that we written by hand, including how to get to the property name. So this is, I think, one of the easier ways to actually get to the name. There also is this info button, which will say the name right next to it, and you can copy it straight away as well. So the easiest way is to actually just get it straight from the software. Yes, Ryan.
So what are the other options, like scale, redundant? So is there like scale relative or scale?
So the question is like scale.scale seems redundant, and it is. Basically, it means that, so there's different ways of defining translations, rotations, scales. This one is just the simplest one that just has one scale. Let's take one of the examples as an example. So another scale object, for example, is called non-uniform scale. So if we load that one, and I open it up and we'll go to the scale, we'll see that this one now no longer has a dot scale. Okay, this was a terrible example because this one's also called dot scale. But now it's not just one value, it's 3 values. Similarly to others, there might be another parameter or property that is differently called from scale. It's just, well, it's a scale and it's a scale value. It seems natural to both call them scale. I mean, that's, yeah, scalar scale. But that's more to type, and now someone needs to know what a scalar value is. So that's how you got to the property name. The third example, adding a time. So that's one of the features that doesn't exist in the user interface. So you can just set whatever time you want as an optional parameter. And then last one is basically the same example we looked at with setting the wall clock time to be the current OpenSpace time by just taking a value, and we take the output of a second function, modify it in some way, and set that as the new value.
That last number always be like a duration, like that 5?
The question is if that last argument is always a duration. In this function, yes. In the fade in and fade out, also yes, but it doesn't have to be. So when in doubt, consult the documentation. So in this case, for example, we have set property value single, which has the URI, the value, and then it says that the third argument is the duration. And there are other ways to manipulate as well.
Is the default just the default immediately?
Correct. The default value in this case is the same as if you would write 0.0 as a duration, which is instantaneously. Single quotes versus double quotes. It doesn't matter as long as they match. If you open with a single quote, you have to close with a single quote. Same vice versa, which means you can mix and match. So if you want to have a double quote within a single quote, that works. But you can't have a double quote within a double quote, because the opening double quote of the second time would close the first one, so to speak. Yes?
The other parameters of this function, for example, know, for example, what they were? Is there a way to find out?
Yeah, so the question is these other parameters, and specifically the names that are mentioned here, like how would we figure out what sign ease out, for example, means. We don't have that on our end, but there is, what's the name called? Easings.net, which basically gives you, based on an input on the x variable, what the corresponding y variable is. So
Where did you go to that?
easings.net. So these ones are different easing functions that are used in a different number of different parameters.
That's
So
the website, easys.net.
correct.
Is there a website for every one of those other words?
No, this is this web page describes most of the ways how to do the easing.
I see.
So the words down here, those ones would be the same parameters, similar parameters. And basically that controls, by default, as it says, it's linear, so we just linearly interpolate it, but if you want to have some exponential, for example, you can change that. I mean, this is getting into pretty advanced territory to tweak things. I would try them out, or Googling these. These are pretty standard terms in computer graphics. So they're, like, that's how I ended up on this easings page the first time. All right. So we're probably not going to get through everything, but the next part that I wanted to talk about are different assets. I hope that everyone's at least looked at assets at some point to load them in, for example. Like, as you just saw me dragging in an example, that's loading an asset file. The nice thing now that we know roughly how to start using and manipulating Lua, is everything is Lua, including asset files. So every asset file description is just a Lua script under the hood. So for instance, if we have a look at, let's take the asset file that I just dragged in. So this is the, if you didn't see it, this ellipsoid that we're rendering right here, that I dragged in. That one's defined by this asset file. And I hope at least you'll be able to follow these asset file roughly. So we have a table, so that's this associative structure, so which is keys and values. In this case, the value, for example, is the identifier, the transform. In this case, we have a scale of a specific type, what the scale values are, what the renderable is, which like basically doesn't matter for now, where the GUI is. We pass this object to a function that is already defined. So it's exactly the same that we've been doing, just slightly more of it in a way. So the nice thing is that every asset that is written in the software is all accessible. Like, there is nothing magic going on behind the back. So if you want to figure out, like, where is Earth being defined? Or there is the location for the asset that defines Earth. There's another asset that will define Earth's atmosphere. There's another asset for defining where the stars are coming from, for James Webb Space Telescope. But also the keyboard bindings. So the fact that pressing F toggles the rotation friction is defined in an asset. So everything that is happening at runtime originates from an asset file. And it's just a matter of finding the correct asset file to figure out where something is happening. And lastly, including the user interface. Like, that is defined in an asset file as well. So it's a very, very generic concept that loads basically anything that is dynamic. Yes?
Can you load a massive amount of asset files, just use a few of them during the presentation?
Question is, we can load massive amounts of asset files, but only use a few. And yes, so a lot of the data sets by default are already disabled. So for instance, if I go to the cosmic microwave background radiation, we only have the Planck satellite enabled, but the other ones are defined in an asset file. They're just not shown by default, so they're disabled.
Like, if I wanted to load all the asteroids, for example, that's not in there
Yeah.
before. Right, so I could load them up also,
Yes, correct.
and it wouldn't slow it down my work.
if that, so basically the question is if you want to load all of the asteroids and if it slows down the rendering, that is a more difficult question. If your computer is strong enough to load everything, then it won't affect the rendering. If at some point you load so much that it's too much for the computer to load, then it will affect it even if it's not shown. So I would be careful, but you don't have to be too careful with what you're loading. It's hard to tell.
Very big computer.
Or buying a very big computer. Yes, that solves. That's a very money solvable problem. All right. The other thing that is good to know, not necessarily vital to know, but I want to quickly go through it anyway, is that all of the different assets that get loaded, they start building up a graph structure, which, like, if you don't know what it is, it doesn't matter, but basically an asset file can request another asset file. So for instance, the Earth's atmosphere asset needs the Earth to be loaded. So the Earth asset file will contain a line called asset.require Earth, which means that if I load the atmosphere, I will automatically get the Earth with it. So there is no way to get Earth's atmosphere without also getting Earth. So there's a requirement dependency that you can set in an asset. And that basically starts building this graph structure that we're seeing right now. So for instance, if you try to unload the Earth, but the atmosphere is still loaded, it won't do anything because the atmosphere is keeping the Earth alive, so to speak. It's fairly rare that you're actually going to be needing this in your own scripts or in your own assets when you start building them, because normally it's like you build everything in one file and it's already in one file, so there's no need to build requirements. But if you make something that needs JWST to be there, then you need to have a requirement there, because otherwise someone might come across your asset file, drag it in, and JWST is not there, and all of a sudden you get error messages all over the place. So there's just a good habit to get into. Okay, so these ones we'll not do as a group exercise. We'll just go through them. So one of the fundamental pieces of an asset file is this onInitialize function. This one's a bit special since the argument that this function takes is another function. So we're basically passing a function to this function to be executed. So if we have this asset file, and if this is the only thing in an asset file, and we're dragging it in, the moment the asset file gets loaded, it'll set Earth scale to 1,250 times. So this is how we would be able to now, all of the examples that we did earlier, to bake them into a file that we can reuse them later. So if I do this here, I'll copy and paste. So this is exactly what we had on the slide. And do an example.asset. Go to my desktop and take the example asset. Let's look at Earth first. So I haven't done anything with Earth, I believe, but the moment I drag this in, Earth now became 1,200 times larger than it was before. Oh, I disabled Earth. That's why we don't see it. But yeah. Just click left mouse button and drag in the file into OpenSpace. That loads the asset file. So I just clicked, dragged, and let go of the mouse button.
Right on the screen.
Right on the rendering screen.
Not in
Correct.
the console.
Correct. Just anywhere on the screen. So this is starting to get us into being able to reuse different things so that you don't constantly have to open up the console, type in things manually, because that can get quite tiring, particularly during a live show, because you don't want to do that. Another concept that we don't really have a formal name for, like I call them meta assets, is this asset file, for example, that it just has this requirement statement. So that means that this asset file needs these other 3 asset files to be loaded, which means that if this asset file basically says, if I drag this in, it'll automatically load the inner main belt, the outer main belt, and the potentially hazardous, rather than me needing to go in and drag all three manually and like by hand, basically. So this is how you can start building, like, yeah, as I call it, meta assets. So for instance, the JWST that I was talking about, assets, scene, solar system, telescopes, JWST, and here we have the JWST asset. So what this JWST asset does is require in the local folder actions, field of view, label, mission, model, view event, and then L2 and L2 sunline. So these are all different assets that define their own things in their own right. And I don't know why this is actually empty. This is a bug. The actual asset doesn't do anything apart from that. So it doesn't have any functionality of its own. It just reaches out to other assets and drags them in. And if or when, depending on which one you go, you start making your own assets, I would recommend not putting them into our data assets folder, because that makes it hard to migrate from one version to the next. So that's why we have this user data assets folder. So the moment you start OpenSpace, there's going to be a user folder that is created where you can contain all of your own files. Because then you just need to take that user folder with you to the next version. And if we didn't screw anything up, it should all still work. And if it does, let us know, because then we need to fix it. Yes?
Can I load an asset from the console?
Question is if you can load an asset from a console. And yes, everything is a Lua script. So if I open the console, there is a OpenSpace.asset.add, which was executed the moment I dragged and dropped the asset file. So even that act was just generating a. And to go even one level meta more, the script that gets executed when I drag a file is also just Lua. So we have, so if the thing that I dragged as an asset file, execute this script, which is OpenSpace.asset.add. So if you want to add your own, like, it's right here. I don't expect that will be necessary, but as I said, everything's a Lua script, so including all of the handling of files. This is one of the example assets that already exists in the system. To very briefly go through it, is we create a new image that contains a single color. So it's an image of a pixel, 1 pixel by 1 pixel, in this case with a cyan color. We define a new table that becomes our new scene graph node. In this case, we need to give it an identifier. That's in your examples where you wrote Earth, Jupiter, Saturn. That was the identifier of Earth, Jupiter, and Saturn. So that one has to be unique. So you can't have two nodes that are both called Jupiter, or you get an error message. So you need to give them a slightly different name. The renderable, which I hopped over before, which I can't do anymore, it's a concept that we use for anything that shows up on screen. So anything that can be visible on screen in the 3D world is a renderable. There are quite a few of them, and the documentation is your friend. So under all asset components, we have all of the different renderables that can exist. So the ones that we looked at so far is renderable globe for Earth, Mars, Jupiter, Saturn. We saw the stars, so those ones are renderable stars. And there's a whole bunch of different things that can do all kinds of objects. So in this case, the example that we're looking at is a disk. So it's just a flat 2D disk that is round by default. We give it a size, we give it a width, and the texture that we have created up here. And then in this asset file, in the onInitialize, we add the scene graph node. So basically what this will do is it'll create a new scene graph node that is a disk that is rendered in cyan, and then add it to the scene, to the path examples with this name. So let's try that. We copy. paste. Give it another name, example 2. Octoplua. 2.asset. And now if I drag this in, we should now have a new example, disk with hole. And there we have our disk with a hole. And it has exactly the parameters that we gave it in here. Luckily, it's a cyan color. The hole is about half the width in, and it is a size of 100 meters. Yes?
How do you know where it will go in the 3D space?
Question is, where do we know where it goes in the 3D space? I didn't specify anything, so it'll show up in the solar system barycenter. There is similar to the scale that we started manipulating, there's another transformation called translation that will move it somewhere else.
And the units for that in line?
By default, almost everything we do in terms of units is SI units, so it's in meters. As an example, and while I'm going there, highly recommend in the data assets examples folder. We've spent quite a lot of time writing a whole bunch of examples for all types of renderables, translations, scales. So this is, I would say, like the first stop to see how to do this, for example, to both of your questions, actually. If I go under translation, we have a translation called static rotation, which means static translation, which means place it somewhere and then just leave it there. So if I open this up, we now have a translation that is this type, and we give it a position. So it's 0 meters along the x-axis, 50 meters along the y-axis, and then minus 10 meters along the z-axis. So if we had this transform in this example, our disk would have been 50 meters along the y-axis, for example. But because we didn't specify anything, it showed up exactly at the solar system barycenter, which is why the glare of the sun is like off to the side, because the glare of the sun is actually at the sun's location, not the solar system barycenter.
If you want to put something in Pluto, it would be in meters.
If you want to place something at Pluto, there's two options. Either you can calculate the position of where Pluto is and then write it in. That has the problem that the moment Pluto moves away, your object will stay where you placed it. So that's where we don't have an example slides, but one of the parameters, go to one of the other examples. That's a good example that is easy. Let's take the ISS, for example. So, go to planets, Earth, satellites, MISC. No, let's not do the ISS. The ISS is great. Let's do the GPS satellites. So navigation, GPS. Same structure that we've looked at. We define a table. We pass on the table to the add scene graph node. So this is the one that will render the collection of GPS satellites. You can see in here, then we'll ignore this for now. Imagine it says this. So what we're saying is the parent of this scene graph node is the Earth. So in the previous example, we didn't have a parent, and the default is solar system barycenter. But if I say the parent of my scene graph node is the Earth, the coordinate system origin is that scene graph node's position, which also means that if that one moves around, my object starts moving with it as well. So that's what you would do with Pluto as well. You would say, you would give it a parent of Pluto. And then if we do 50 meters and 10 meters along the z-axis, it would be relative to the origin of Pluto, even if Pluto moves around. Yes?
Is that the center of the parent, or is that from the surface of the parent?
The question is if it's the center of the parent or the surface, and it's always the center. There's another translation that is called globe translation, that assuming that the object is a planet, you can give it a longitude, latitude, and altitude, and it will calculate the distance from the center. So that's how you would place something on the surface of Earth, for example. So I would, since we don't have too much time, I would go through the examples. All of them should explain what the example does, and they should also all work. And they're all available in the documentation. So what we just looked at was the static translation. So under references, all asset components, we have our translation, we have the static translation. It explains what the parameters are that are required, whether they're optional or not. And down here we have the asset examples. So this is exactly the one that we just looked at. So they're all available on the webpage as well, which are exactly the same files that you have in your OpenSpace folder too. So we'll skip this exercise, but the solutions are there. I would recommend doing them. It's a good exercise to go through how the different assets are built. And yeah, just briefly in this one, I hope everyone played around with it, but we have this concept called actions, which you can access through this little square blocks panel. Knowing what you know now, I can explain actions as a grouping of Lua scripts. So you define Lua scripts and then give it a name, and it'll show up in this actions. So under the hood, for example, if I go back to Earth, enable it. Whoa, we made it large. And I disable atmosphere as well. Go. So maybe some of you have seen under solar system, Earth global illumination, which will turn off the shadow of Earth, or standard illumination, which turns the shadow on again. So these ones are two actions that are defined that just contain a bunch of Lua scripts. So if we open that up, and I'm actually not 100% sure where they are located myself. So I'll use the search function for that. So it seems to be data, assets, action, planets. So we don't need to go through the content, but, and this is also a terrible example actually. Take a different example. This one's more involved to make more things work. Yes, let's do this one. Zooming out, we have the trails in the solar system. Under trails, we can hide all trails and show all trails. Which, if we look at all of the scene graph nodes and hide all trails, you'll see that they should all disappear. And we should have checked out here as well. But basically, it's a button that saves us from going through the individual checkboxes and manually clicking all of them. So this is one of the prime examples where making them as an action is really useful, because you can combine a whole bunch of complicated things in a single button press. So here we have the show all trails and we have the hide all trails. So the way actions are defined is they need an identifier, which has to be unique. Doesn't matter what it is, as long as it's unique. We have a name that shows up in the user interface. We have a GUI path, so where in the folder structure does it show up? So in this case, we have /trails, and it's called show all trails. So that's why I had to go into the trails folder, and then it's called show all trails. That's where that name is coming from. And then lastly, we have the command, which is a Lua script that gets executed whenever someone triggers that action. So for instance, if we take that example that we had from earlier to make Jupiter twice the size of Saturn, if I were to put that as a command into this action, I would now have a button to make exactly that happen again without needing to type anything in by hand. So usually the workflow that we have is making scripts by typing them in by hand and then canning them into an action to make them easily accessible by just a single button press. And that's basically things you can customize on your own depending on what you need necessarily. And the way we tell OpenSpace that there is an action, we have a function for that. So in the onInitialize, there's OpenSpace.action.register action, which gets this whole table, and then OpenSpace will know about it and display it in the user interface. I didn't really have a good place to place these. I mean, we talked about the PostScript already, that calling a function once interpolation is finished. A couple of other interesting functions that might be useful to do something cool is OpenSpace.walk directory. So you pass it a folder on your computer, and it will return back to you all of the files and folders in that folder. So for example, one of the things that we build in our institution is we have children coming in and drawing on paper what their planet should look like, and then we have a system that scans that in and automatically places that JPEG into a specific folder. So when we start up OpenSpace, we use this function to go through and automatically create a random planet in a random orientation based on every image. So the only thing that our presenters need to do is place the images in that folder, start OpenSpace, and it will happen automatically. So that's one of the useful use cases for this. If you start making your own things, reading a CSV file is pretty useful. So it just returns back the contents of the CSV file in Lua. So you can do whatever you want with it, like create scene graph nodes based on what is specified in a CSV file if you want to, if you don't like making things in Lua. And then one thing that we added fairly recently is register repeated script. So it basically means that you pass it a script that you want to execute and in which intervals you want to execute it. So if you want to print an error message every 3 seconds, this would be the function that you want to do it with. Or if you want to, I don't know, increase the size of the planet every 2 seconds or something like that. I'm not really sure what you want to use this for, but it's probably going to be useful. So we have 10 minutes left. The next thing is the navigation part. So we're going to be moving away a bit from the scripting. Are there any urgent questions? I know we've gone through some of the things a bit faster. I don't expect anyone to remember everything. That's why we're sharing the slides. And we're, of course, there for questions as well. Yeah.
Set property value, being able to change things around or a renderable thing. Where can we see the list of properties that each object has?
Question is, how do we know what properties exist for an object to use them in a set property value? The easiest thing, and now keep in mind, I have mine set to developer, which is almost the same as advanced user. So yours might not look like exactly the same. So for instance, if we take this ellipsoid, if I open up by clicking on it, I get the view of all of the properties. So everything that shows up in this menu is a property, meaning it can be set by the set property value. So for instance, we have like the opacity. So if I drag it down, it disappears. Now that I'm mucked with it, I can go to the script log, and it's right here. Scene.non-uniform static scale _ example _ ellipsoid.renderable.opacity. Or alternatively, this little info button next to it. So for example, the color. So if I click the color, it'll have the name of the property at the bottom. We try to be fairly sensible with the names. We don't always succeed. But in this case, if I copy it and then say OpenSpace, set property value, paste. Let's make it red. It'll change the property to red. One thing to keep in mind here now is that with our user interface, we try to be sensible in allowing what you can do with it. Once you start scripting, all gloves are off. Like, you can do whatever you want, and it's not super hard to make OpenSpace do something that you didn't want to, or make it crash as well. So for example, with a color, I have even no idea what's happened, but if I set the color to -1, which doesn't make any sense, it just disappears, and we can see it like the grid's still there, but it's rendered in black. One of the good anecdotes for this one was actually with Dantel from California Academy. He wanted to simulate, I think it was some infrared image of the Milky Way. So he mucked around with setting some negative colors in order to take green out of another image that is behind it. So that's kind of the hacking functionality that scripting gives you access to, which might change from version to version, but worked in that case at least. Like, the takeaway message is that try it out, nothing breaks by default, but now with the scripting, things might crash, but well, you can always restart OpenSpace and everything's back as normal, because we don't save anything by default. Any other questions? So there's a whole bunch of different Lua functions that are available. So we looked at maybe 10 out of, I would guess, 200 or 300 different functions that are available. All of them are documented to varying levels of success. In general, the more documentation is available, the more important the function. It's a very rough estimate, but like, that's a good indication at least. And yeah, it's possible to add your own functions, but if you need something, let us know, and we can add it pretty quickly as well. All right, and then we also had custom navigation in this session, so I want to touch on that at least a bit. So in the beginning, I was saying that everything in OpenSpace is Lua, except for camera movements, with one exception, and this is the exception. So there are Lua functions that are up here. So the first one is save navigation state, which stores the position of the camera and the current time in OpenSpace and the orientation of the camera in a JSON file on your computer. And then you can later recover it using the load navigation state, jump to navigation state, or fly to navigation state. The difference is being load does it immediately, jump fades out the rendering to black, loads the navigation stack and state, and then fades it up again. And fly to, well, it uses our camera and flying system to fly to somewhere. So, for instance, if I do OpenSpace navigation, save navigation state, I give it the location where I want to save it. State, JSON. Now that I executed it, in my OpenSpace folder, I have a navstate.json that contains what's the name of my current anchor, what's the pitch, so how far from center of screen am I currently, and apparently I pressed control at some point. What's my position in, should be meters, not 100% sure. The current timestamp in OpenSpace, what direction is my up, so which direction is the up vector pointing, version, because we might want to change it later, and then yaw, which is like the rolling, I think. Not 100% sure actually right now. But with that file under the hood, I can now move in and can say, instead of save navigation state, load navigation state, and we're back to where we were before. Same thing if I rotate around here. Do fly to. What did I do wrong? Oh, the fly to it doesn't take the parameter. Never mind. It wasn't fade, it was jump to. And that also doesn't take the file. It takes the actual contents of the file. It's not as smooth, but like you know how to script now, so we can at least.
Wait, sorry. So you can't feed it a file. You have to give it the actual coordinates.
Correct. So let's actually have a look at it. So fly to navigation state. So scripting, navigation. So if we take the load navigation state first, it takes one parameter that is the file path that we just saved, and fly to navigation state takes a table with all of the parameters. So for the fly to navigation state, it takes a table that has anchor position, aim, pitch. So it's the contents of the file rather than the file itself. We're building these functions one at a time, so sometimes we have a bit of inconsistencies in here, and this is one perfect example. Which also is hard for us to fix because some of you might require this function now. So if we change it, we're going to break someone's code, which is also not great. But yeah, basically this allows us to, in an action, for example, if you know that you always want to start in the same location, you can store the navigation state and then restore it whenever you want to. Yes?
So, for example, if I wanted to press a lot of action buttons and travel around the solar system, I would just go navigate to Saturn, and there would be Saturn. Press another action button, there would be Jupiter.
Yeah.
Right? And it would just be right there on my action buttons.
Correct.
And in the navigation state would be where it's pointing at that exact moment.
And where the camera is, yeah. Yes, exactly. So basically you can store a bunch of navigation states for going to the different planets and have them set up correctly to your preferences. One thing that I didn't mention is this load navigation state has a second parameter that is whether we should use the timestamp in the navigation state or not. By default, I think we don't, which means that if I change the time and I load the navigation state, yeah, it does not reset the state. One thing to keep in mind here is that everything in space is moving. So if we go to Earth, for example, let's save the navigation state. And we're now in August. Let's go to February. If I now load that navigation state that I just did, we are not going to. Oh no. I might have been too close to Earth. Okay. Yep. I think we changed it recently to address this problem exactly. So the navigation state is relative to the object that we're looking at. So what I want to do is, yes, correct, the anchor. So if I focus on the sun, and let's do this again. I save the location. I go to March. So if I load it and I don't pass anything, now nothing will happen because we're in that location, but Earth has moved away. So if I want to also restore the time at which we were before, I pass in true, and now we're setting the time correctly. My point here being that if you store navigation states for planets and you want to restore them, you also have to restore the time. Otherwise, the planet might be in a completely different location and everything moves different.
So you change the anchor to what you're looking at there, but the navigation file has
it has a position and the name of the anchor. Now, because I changed it to sun surface, it will say, well, in this case, sun. And then it's now relative to that, so we're, whatever that is, meters away, I mean, like a bit more than an AU away from the center of the coordinate system.
You also use relative file paths in that?
Can we use relative file paths? Yes. Yep, we can. It's time for lunch soon, but yes, you can. In the console, I wouldn't necessarily recommend it because you don't know what the current folder is that you're relative towards. In order to solve that, we have yet another function that is called appsPath, which you can pass in. I'll just explain this as magic. appsPath with this base is the main folder of OpenSpace. So whatever OpenSpace folder you have started, wherever is located on your computer, the folder where the OpenSpace.cfg file lives is base. Same thing with, I think bin is the name of the folder where the OpenSpace.exe was that you started.
Isn't there also a user though? So you could save like your JSON to a user folder?
Correct. We don't have a nice way to look at that right now, but we have our ugly old way of how the user interface used to look like. It can't be scaled, so it's a bit small, but you can access it by pressing F2. And then it has a checkbox called File Paths, which contains all of the different, what we call path tokens that can be resolved. And one of them is user, and there's another one, user assets, user config, so they're all available to in here. Alternatively, in the OpenSpace folder, there's an OpenSpace.cfg. If I scroll down a bit, they're all defined in here. So if you want to create your own, you can just define that in here and use it wherever. Cool. All right, so negation. There is keyframing. Talk to me in the break. Basically, you can define different keyframes and jump through a set of these kind of keyframes, save them, restore them. And then the last things before lunch, obviously, because of time, not going through in detail, everything we just did in Lua, we can also do in JavaScript. So if you have a web page, all of the people that build their own button pages, you've been basically doing this, just not knowing that all of the JavaScript stuff gets converted into Lua. So you can do everything with JavaScript. And Python. So same thing, we have a Python API. Everything we did in Lua, we can also do in Python. And again, talk to me about it at the break. And there's no more slide. Now it's lunchtime. Thanks for your attention.